Welcome to ClickMyProject.com. Now we are going to discuss about the project rice grain classification using multi-class support vector machine. Now we are going to discuss about the abstract of the process. The main purpose of this project is to present an image processing based on the solution to classify the different varieties of the rice grain based on the images. An approach based on the combination of features, extractions and classification method. These two methods plays a vital role in this project. Variety of rice grain is determined by morphological features such as the HSV, mean standard deviation and variance of the rice grains. The dataset consists of the different kinds of the rice grain varieties. So we have to choose any one image from the dataset. Based on that selections, the classification will be done by comparing the sample images with the database images. Hence, the SVM is used to detect the type of the rice grain. Then the classifier performance will be evaluated based on the accuracy, sensitivity and specificity. Based on these three parameters, we can justify our process as good. Based on the accuracy, if the accuracy is above the 95 to 90% in the sense, it will having the good performance of the classification. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this project. The project consists of the modules such as dataset, input image, then pre-processing, feature extraction, classification and finally performance estimations. At first, the input rice grain image is taken from the dataset. The dataset image consists of the lots of grains such as the three kinds of images will be there. After taking any one image from the dataset, the pre-processing will be carried out. In this pre-processing, grayscale conversion is carried out and then the noise filtering and resize will be carried out. So grayscale is the main color conversions, which is converted the RGB image into the grayscale images. Then the resize is carried out to maintain the aspect ratios of the images based on the number of row and number of column of the images. After doing the pre-processing, the feature extraction is carried out by means of the three kinds of the parameters, which is the mean, standard deviation and variance. Based on these three parameters, we can extract the features from the images. After doing the feature extraction, the classification is performed by means of the support vector machine. Here we are using the multi-class support vector machine to classify the three different kinds of the rice grains. After classifying these three things, we have to perform the performance estimation of the project. So the performance estimation is based on the accuracy, sensitivity and specificity. Based on these three parameters, we can justify our process is efficient or not. In case the accuracy is above the 90 to 95% in the sense, the accuracy of the classification is good. So these are the overall performance of the project. Now we are going to discuss about the overall working procedure of the project. At first, open the Matlab 2019B and then change the current directory. If you want to execute the process, just right click in the main_GUI.m and select the option run. Once you selected the option run, the user interface will be open. In that user interface, you can see the several buttons in the right side and then the several axes and table in the left side for the controlling actions and then the display actions. At first, open the dataset by clicking the input image. Once you click the input image button, the dataset will be open. In that dataset, you can select any one image from the dataset. After the selection of the image from the dataset, the corresponding image is shown in the axis 1 with the title of input image. After doing the selections, we just move to the second stage of the project, that is the pre-processing. So in this pre-processing, we have two kinds of pre-processing step is there. One is the filtering and then the resize. So after doing the filtering, if in case any noisy pixel is occurred in the image, it will be removed. Then doing the resize, it will enhance the size of the image by improving the row and column of the image. After doing these two things, automatically the image will be converted into one grayscale image. Then we have to extract the features by means of the feature extractions. Here we are extracting the features like mean, standard deviation, as well as the color features such as the HOG is extracted. Those feature values are shown here. After doing the extraction of the features, we just click the train features to extract the overall train data from the overall dataset images. There are lot of training feature is there, so that features are extracted and then visibly in the table 2. After doing the feature extraction, we just move to the classification steps. Once you click the classification steps, the train test feature is matched with the train features by means of the support vector machine. After doing the classification, the classified result will be displayed here. Once the classification was done, the classification result will be displayed here in the name of the basmati. So after doing the classification, the performance will be evaluated. So the performance will be evaluated by means of the accuracy, sensitivity and specificity. Those values are plotted in the graph as well as in the chart values. So you can see the values in this table, as well as the values are represented in the message box also. Now the accuracy is around 99%.